Okay, so for this video onwards, we are going to discuss about chapter 2, which is about function. All right, and then I believe that most of you learned function before, but for A-level syllabus, they are more focused on domain and range. So I believe that the domain and range part is something quite new to most of you. All right, so maybe you learn about the word of domain and range, but for A-level syllabus, they are going to test you more on the understanding. Like they will actually ask you to analyze from the graph. Okay, so what is the domain for a particular function, or what is the range for a particular function? And then you have to make sure that you really understand the concept of domain and range, because usually when they ask you about to find out the domain and range, usually the steps is not so long, and then you need to analyze a lot, okay, on the graph or maybe on the function. Okay, so let's start with a very basic, all the very basic terms about function first. Okay, so for today's learning outcome, we need to know the meaning of function, domain, and also the range. All right, and then after that, maybe in the next video or in the later video, we are going to discuss more on how to identify the domain and range, okay, of a given function in the simple cases. All right. Okay, so let's start with the very first part. Okay, so the very first thing is we need to know what's the meaning of relation. So relation is between. A relation between two sets is the correspondence between elements of the first set. Okay, so first set, we have one set of values. Okay, we call them as domain, and also the element of the other set we call it as range. All right, so the relation can be represented by arrow diagram and also an order pair. Okay, so maybe I can take a very simple example here. Let's say I'm having a set of value, okay, and I have another set of value. Okay, so maybe I can put something like this, 1, and then maybe I put a 4, and I put a 9. Okay, then here I put 1 and -1. I put 2 and -2. Then maybe I put a 3. Something like that. All right. Okay, so if I try to map, all right, so if I try to map value 1, okay, to 1, and also value 1 to -1, okay, and then maybe for 4, I can map it to 2 and also -2, okay, and then for 9, I map it to 3. Okay, so the blue color part here, we call it as relation. So maybe I can define the relation as is the square number of, so that means 4 is the square number of 2 and -2, something like this. Okay, so when we define it, so this we call as relation. All right, so when you have the very first set, okay, of the elements, we call it as domain, and then for the mapping part, right, we call it as range. Yeah, and then all the values inside you can call as value, or you can call it as element. All right, so this is the very basic idea about domain, relation, and range. Okay, and then this whole figure, I call it as arrow diagram. And in most of our reference book, all right, when we talk about the function, generally they prefer to use arrow diagram, okay, to represent the relation or maybe to represent the function. Okay, then what is ordered pair? Ordered pair means that they are actually writing out the domain and range. Okay, so in a set of values. So as example, they might write it like this: 1 and -1. Okay, and then 1 and 1. Then 4 and 2, you will have 4 and -2. And then you have 9 and 3. Okay, and then maybe in front you will write lah. Okay, so is the square number of. Okay, so this is something that we write our function in order pair or relation in order pair. Okay, but we seldom see this kind of pattern. All right, we seldom write out our function or relation in the order pair. Okay, because generally it looks very confusing most of the time. All right, because when we learn coordinate geometry, right, you also write it in a bracket form like this. So sometimes when people read, okay, the values and so on, they will actually miss. How to say? It is quite misleading. I can say the way that we write it out in the order pair. All right, so it is quite misleading. So we seldom use this. So we prefer to use the arrow diagram to actually represent the domain, to represent the relation or the function. Okay, all right. So in general, there are 4 types of relation. Okay, so 4 type relation means one-to-one relation, many-to-one. Okay, so one to many and also many to many. Okay, one-to-one is very easy. You will see that one value will be assigned to another value only in the range. Okay, many-to-one means that you might have 2 values, okay, which is mapping, okay, to the one value in the range. So this many-to-one. Okay, so one to many also very simple. You have one element in the domain, it will be mapped, okay, into different values in the range. So we call as one to many. And then many to many is a very complicated one. You have many to one, you have one to many, and so on. That's why in short we call as many to many. All right, so there are 4 types of relation here. Okay, so all these are not so important because it is just for extra understanding only. Okay, right. So now we talk about function. So what is function actually? Because our main idea is to learn function, right? Okay. So for function, it is a special case of relation. So relation got 4 types, right? Okay. So out of the 4 types of relation, we have special cases. So those special cases, we call them as function. Okay. So how can we define as function? Okay. How can a relation being defined as function? So generally, this is the definition. Every element of domain, okay, are assigned to one and only one element in the range. Okay, so this is the definition of it. Every element of domain, okay, is assigned to one and only one element in the range. Okay, so as an example, in short, they will actually say that one-to-one function or one-to-one relation and also the many-to-one relation are function. One to many, many to many will not be the function. Okay, so why one-to-one and many-to-one are function? Because they say one element mapped to one element only. Okay, that's why we call it as function from one-to-one and many-to-one. Right, so we can have a look for example number 1. Okay, so they're asking which part, okay, which diagram actually shows that it is a function. All right, so and they want you to give the reason. Okay, so for first part, the answer is yes, it is a function. The second part, it is also yes, it is a function as well. The third part is no, and the last one is no. Okay, so for this one, first part, why is it a function? Because it is a one-to-one relation. Can see that A map to 2, B map to 1, C map to 3. Every single element in domain is mapped to 1 element in the range. All right, so it is a one-to-one relation and therefore it is a function. And then for part number 2, for part number B, it is very similar to part number A, just that in the range you're having some value which is not. Okay, so in our definition, we are not concerned about this, right? We're only concerned about the element in domain are all mapped to one and only one element in the range. All right, so in the range, if let's say there are some value which is not assigned, then it's fine. Okay, so this one is still a one-to-one function. One-to-one relation, and therefore we will define it as a function. Okay, then for part C. So for part C, very obvious it is not a function because of this. Okay, so there's a one-to-many relation, therefore it is not a function. Okay, then maybe the last one, a lot of you might feel confusing. Okay, if you look at A is assigned to one value, B is also assigned to only one value, okay, and then why it is not a function. Okay, so the answer is here. Okay, if you continue, if you read again the definition, they say every element, okay, in domain must be assigned to one and only one value in the range. All right, so if you look at this one, the C here, you realize that it is actually one of the element in the domain, but it is not mapped to any value. So it actually not fulfill the definition, okay, of the function. Therefore, you can write if they are asking for it, you can say not every element, okay, in domain are assigned, or you can say are mapped, all right, to one value or one element in range. Okay, so for this part D, the reason is because of this. All right. Okay, so no matter how, all these are just a very warm up concept for you, okay, to understand what is relation, what is function, and so on. All right, in exam generally, they won't ask you about this, but this is for extra understanding and to start to let you know basically what do we have, okay, and what is the difference between the relation and also the function. Okay, then let's continue further. Right, so when we come to the next part, which is very important, okay, let's talk about the domain and range. Okay, so for domain, usually from now onwards, when you read the exam question or whatsoever, right, when that particular question related to function, you will see that after the expression of the function, they will put a comma and followed by some value of x. Okay, so like this one, the highlighted one. So this is actually the domain given by the question. Yeah, right. So actually when they write the domain, right, okay, so they will say this is x. So, okay, what is this symbol here? This symbol here is an element of, okay, R means the real number. Okay, so in short, x can be any real number. It also means that x can take any value from negative infinity to positive infinity. Okay, real number, so real number can be any number, right, as long as it is real. Okay, so real number also means that from negative infinity to positive infinity, you also accept it. Right, so in short, x is also from negative to positive infinity. So this whole thing is actually the domain. And then usually for domain, it will be given in the question. Unless they want you to find out the domain yourself, that means they might want you to use some concept to find out the domain. Okay, so for now, we focus on this one first. So usually they will write out the domain after the expression of the function. Okay, and then what is the meaning of domain here? Domain means what? Domain means is the set of values of x. So we are talking about the values of x for which fx is defined. Okay, so as an example, if let's say I'm having a graph, let's say okay, so let's say I have a graph here. I simply draw a graph, and then maybe my graph the shape is a circle, let's say a circle. What is the center and everything, I don't know. Okay, maybe I draw it in other place better. Okay, so maybe I draw a circle here so that you can understand it easier. So the circle is a function, let's say. Okay, so when you say about the domain, right? So when you talk about domain means what? Means that the value of x that your graph start and your graph end. So as an example, like this one, if let's say in the graph they draw a circle, and then you know that this smallest value on the horizontal part is actually maybe 2, let's say, and then this value, maybe they will tell you that it is a 4, let's say. Okay, so that means from 2 to 4, this is actually your domain. That means between 2 to 4, your graph exists in this range, this value. So we call it as domain. All right. Okay, and therefore here they say domain is the set of value of x. Okay, can all right. So this is why we define it as domain, and basically it's like that. Okay, then we talk about the range. All right, so for range, it is actually the set of values of y for which the elements in the domain can. So just now domain is the value of x, so range will be the value of y. So the same thing happened here. If let's say you're having a circle as your function, then the range is you need to look at the highest part of your graph. So the highest value of the graph maybe is 5 here, let's say. And then maybe for here, they label it as 1. So this is actually the range. So when you find the range, okay, let's say it's 1 to 5, right? So you can as 1, y is between 1 until 5. So for the x value just now, you can write it up as x is between 2 until 4. So this green color part we call as domain, and the blue color part we call as a range. All right. Okay, so this is some basic idea that we talk about domain and range. Okay, so again, function with similar expression may have different domain, and hence it is possible that the function have different range too. Okay, so for the value of x domain and also the value of y the range, generally it is not standardized. I mean, different question, when they give you different domain, you might have different range, although the formula of the function is the same. Okay, so we can take some example and we discuss it here. Okay, if you can have a look for example 2. Right, so if you compare example 2, generally what do you have is you are having 3 graphs here, but all the functions have the same formula, which is same expression, x squared plus 3, x squared plus 3, x squared plus 3. The difference is what? The difference is the domain given at the end of the function is different. So for the first example, they give you x is an element of real number. Okay, and then for part B, what they give you is x is greater or equals to 0. And the part C is x equals to 1, 2, 3, 4, 5, 6. Okay, all right. So when all the domains are different, how are you going to sketch a graph? And how are you going to find the range? All right, so because we haven't learned how to sketch a graph yet, so I will just give you and tell you the answer. When I want to sketch y equals to x squared plus 3, generally the graph will look something like this. Okay, so it is a U shape, and then this value is a 3, and they are symmetry. Okay, so symmetry to each other from left to right. Okay, right, so this is the basic shape. Okay, now I want to put this basic shape in my first equation. Right, so first equation, when they say that you are having x squared plus 3, when x is any element, is an element of real number, which means when you want to draw the graph, you consider the whole part of the graph, the complete part of the graph. Okay, so you draw a U shape. Okay, sorry, my graph is not symmetry. I try my best, but you try to make it as symmetry as possible. Right, so this value is a 3. Okay, and then when they said x is an element of real number, that means that your graph, okay, so you draw it from the left to the right hand side, whole part of the graph. All right, okay, so this is the shape for x squared plus 3 when the domain is a real number. All right, okay, next, let's continue to part number B and we compare it with part A. All right, so for part number B, they are asking you to sketch also the graph for x squared plus 3. So the x squared plus 3 originally will look something like this. Okay, so this is 3. But now, because they are asking for x greater equals to 0, so where's x greater equals to 0? So this part, you know that it is x greater than 0, and then this part will be x smaller than 0. So the domain here indicates you to just draw the graph that the domain is x greater equals to 0. The x is positive. So that means you only need to consider this part of the graph. Because only this part of the graph, the x is greater or equals to 0, right? Okay, and therefore your graph will look something like this. Okay, so please compare part A and part B. You can see that the domain are different. Therefore, the final graph that you draw up are different also. Can you see? Part A is U-shape, part B is not the U-shape, it is only half of the U-shape only. Alright, so you can see that actually the domain will affect your graph, the shape of the graph, although the expressions is the same. Okay, alright, so I hope that you can understand this part. Okay, then how about for part number C? Okay, so for part number C, again, if I want to sketch the graph, Okay, now they are asking you to sketch the graph only for 1, 2, 3, 4, 5, 6, the 6 values here. All right, so again, I'm having the original graph. It is a U shape. Okay, so now for the domain part here, they ask you to consider 1. So where's the 1? Maybe 1 is here. Huh? Okay, so this is the 1, let's say. Okay, and then when you put the 1 into the function, you have a 4. Okay, and after that, they want you to consider the 2. So let's say this point is a 2. Okay, and then the value here will be a 7. Okay, then maybe this is a 3. Okay, and then this is 4. And then this is 5. Okay, and this is 6, let's say. Okay, and then if you can label out all the values here also. Okay, so my space is not enough, not big enough. I'm not able to label it up. If you can, you try to label it. So like 6, right? 6 square is a 36 plus 3, you get 39. Then you have 25 plus 3 is 28. And then 16 plus 3, you get 19. And after that, 3 square plus 3, you get 12. Okay, and so on. All right, so because for this example, they are asking you to consider only the 6 values here, which is 1, 2, 3, 4, 5, 6. Therefore, your final graph will look something like this only. This is your final graph with 6 points only, 6 blocks. Okay, so this is the meaning of having this kind of domain. All right. Okay, so you compare A, B, and C. Everything here are x squared plus 3. But when the domain is different, therefore you can see the different shape of the graph. All right, then now I want you to add on another one maybe. Okay, if I want you to sketch fx, it is equals to x squared plus 3, and then x is between 1 until 6. Okay, if I want you to draw this expression function with domain, with this domain, so how will your graph look like? Okay, so when they give you the interval x is between 1 until 6, generally when you draw it, right? Okay, so again, originally you are having the U shape here. Okay, so they want you to start from 1. So that means maybe when you start from 1, this is a value of 1. Okay, and then what's the value here? 1 squared plus 3 is a 4. And then the last value they want you to consider is a 6. Okay, so let's say I label this as a 6. Okay, then what is the value here? The value here will be 6 squared plus 3, which is 39. Okay, so they want you to consider everything between 1 until 6. So that means they want you to consider this part of the graph from 1 until 6. Okay, so eventually when you look at your graph carefully, then your final graph will look something like this. Okay, and again, for this part D, I want you to compare it with part C. Can you see the difference or not? Okay, so this one is 1, 2, 3, 4, 5, 6. Therefore, your final graph got only 6 points here. 1, 2, 3, 4, 5, 6. Okay, and then for this one, it is given in the interval. Therefore, when you sketch a graph, it should be the whole line. Okay? All right, so I hope that you can see all the value here, and then you understand that why do we get all this kind of function, get all this kind of graph, although the expression are the same, but the domain are different. Okay, because of the different domain, and therefore the graph also looks like different, although the expression are the same. Okay, so for this example, right, they already give you the domain. Okay, so nothing you need to argue about it because domain is given. You just need to follow the domain and draw the correct graph only. Let us talk about the range now. Okay, so if let's say from a graph, how can I know that what is the range for the particular graph? Okay, so for the range, you always look for the smallest value in the graph. So this is smallest value in the graph, right? Which is a 3. And then the graph keeps on moving up, correct or not? Move up. Okay, so the graph moving up. Therefore, the range cover from 3 onwards. So when you want to write out the range, okay, it is actually y greater equals to 3 because the smallest value is 3 for your graph. and then the graph keeps on going up. That means the value of 1 will increase. Okay, therefore, when you want to write out the range, so it will be more, any value more than equals to 3. Okay, so this is how we write out the range, like this. Okay, how about for part B? So for part B, also the same. You look for the smallest value of the graph that you consider. Okay, so this value itself is a 3, and your graph moving up, right, keeps on moving up, and therefore the range covered is also y greater equals to 3. All right. Okay, then how about for part C? So for part C, this is a bit special because they only consider the 6 points here. Therefore, the range also has 6 values only. So what is the 6th value here? You should have 4. Okay, then 7, 12, 19, 28, and also 39. So this is the range for this part C. And for part D, what is the range? Okay, so now for part D, the smallest value of the graph is 4, and the largest value for the graph is 39. Therefore, the range is between 4 until 39. Therefore, if you want to write it out, it should be 4, and then y, and then 39. Okay, so this is generally how we look at the range. Okay, look for the range from the graph. All right, so again, why are we having all these kind of different graph? It is because of we are having different domain, although the expressions are the same. Therefore, the graph that we draw will be a bit different also. That's the first thing that you need to know. And the second thing that you need to know is when you want to get the value of range, right? So you can actually refer to the graph. Okay, when you refer to the graph, you will see that, okay, from the graph, you might get the idea how to get the range of the graph. Okay, all right, so this is some very basic knowledge and introduction about the domain and range and also the graph. Okay, so for the next video and a few more videos later, maybe we are going to discuss in details already how to sketch a graph correctly to show the range and domain correctly. Okay,